a big one of my favourite areas of maths, and that is algebra, which for some people seems to strike fear into their hearts. Others seem to just like it. What I'm aiming to do today is to make more people love it and make more people see the fun in it a little bit more. And it is fun. Just trust me on that. I've even got fruit on the front page. Have a look. So we look at these pictures here. Look at this first slide, and you just see it as a normal puzzle, and it is a normal puzzle. So we're looking at this top line. We've got 3 apples equals 30. So just using a bit of common sense, each of those apples right there is going to be worth 10. 10, 10, 10 equals 30. Then use that information down in the next, I'm not going to call it an equation yet, but the next problem. So we know 10 of it already. We know 10 here. We've got to make a total of 18, meaning that for the 2 bananas that we've got, we have 8 left that we need to account for. So each one of those bananas is worth 4. Okay, 2 lines done already on what is just a fruit puzzle at this stage. Now we can plumb that 4 down there. Use that. We know a banana's worth 4. 4 take away something is 2. Now we know what a coconut is, and that is 2. And then we use everything that we already have here, everything that we've deduced from the problem, and add it all together. Coconut is 2, add an apple, which is 10, add a banana, which is 4, and the answer is 16. Now it looks just like a fruit puzzle, but later on I'm going to convince you and show you why what we just did, was algebra. If I just put some letters instead of the fruit, I'll show you why it's actually an algebraic equation. Why is it important then to know algebra? It's so many reasons. I put my annoying phrase at the top. My annoying phrase for this is get the unknown on its own. What we're trying to do to solve an equation is to get the unknown, whether you want to call that A, X, Y, it doesn't matter. It's just something we don't know that we've given a letter to. We want to get that on its own. And once we've isolated it, we'll then work out the value of it. I'm not going to go through all of this because it would take a long time. But at year 6, you're going to get algebra questions in reasoning papers, either one of the SATs reasoning papers, probably both. And some of the main things that we're going to go through today is use simple formulae, fine. Express missing number problems algebraically. That's almost what we did with the fruit problem. And it even says down here to do number puzzles, some notes and guidance, finding expressions, formulae in maths and science. There's lots we can cover in a short amount of time. Let me just show you. The reason I want to show you this now is understanding algebra at primary school level, not too bad. There's not a huge amount of coverage. It takes a couple of weeks in the curriculum. Mostly it's about 2 weeks worth of teaching. Have a look on my next slide here. These are not even the exhaustive list of all of the algebra objectives for secondary school. It is absolutely massive. And this is why we need to build that foundation in primary so that we know what we're doing in secondary and our heads don't explode when we're talking about different coefficients and things squared and all kind of graphs. So we're going to start with what is relatively basic, understand what we're trying to do, and then we can expand that into secondary school teaching really easy. So instead of having 3 apples equals 30 and working out that it's 10, I'm just going to call it this, 3a equals 30. And then what I always get my students to do is write down the steps that they take to get the unknown on its own. I want to get just one lot of A here. Can't be having 3 lots. So I'm going to divide by 3. That'll leave me with A on this side. And whatever we do with an equation, because it's equal on both sides, left and right, if we do something to the left side, we have to do it to the right side. So my divide 3 works for 3A and for 30, and leaves us with A equals 10. That's the algebra for that. Now for the second line, we've got 2B, 2 bananas, plus the 10 that we already know, equals 18. Again, get the unknown on its own. So I'm trying to get rid of anything that's around B, any of the mess that's around B. I just want B on its own. First thing I'm going to do is get rid of this 10 because it's hanging on to the end of my equation there. I just want rid of it. So take away 10. I'll leave me with 2B on the left-hand side. And whatever I do to the left-hand side of the equation, I have to do to the right. 18 take away 10 is 8. I know my B looks a bit like a 6, but just bear with me. And then to get B on its own, I need to divide by 2. So I've got 2 lots of B. I want 1 lot of B. There's the B. 8 divided by 2 is 4. And that is how we've calculated then that our banana is worth 4. Running out a bit of room here. I will rub some of this stuff out. Give myself some space. Hopefully you've remembered all that. And then what we've got, banana is 4. Take away C equals 2. Bit of an interesting one. I don't like having a negative letter, so we've got a negative C there. So what I would do is add C. It's a little bit advanced, but I'd add C, meaning I nullify this. If I add minus C, and then I add C, I've got nothing, and so it disappears from that side. And then it pops up on the other side because I've got add C. Now I'm going to take away the 2. I've got 2 on this side, C on that side, and the coconut is worth 2, and then C equals 2, and then we can add all those up. But we don't need to go through the algebra of that. The important things to note are whatever you do to the left-hand side of the equation, do to the right. And it just looks a lot more complicated, doesn't it? When you just put 3a equals 10, it looks a lot more complicated than what you're actually doing, which is having 3 apples equals 30, and knowing in your head that each one of them equals 10. So all you're doing when you're doing an algebraic equation, you're solving it, it's just a problem solving game. It's getting that unknown on its own. I'll give you a couple more fluency examples, really basic ones. X's are unknown. It's essentially the same as just having a question mark in there, really. You can call it A, you can call it Y, Z, whatever you want. It doesn't matter. All it is this is an unknown number currently. So to get it on its own, firstly, we want to get rid of this plus 3. So if I take away 3, I get back to 0 and that disappears. That leaves me with 2x. On the other side of the equation, because it's equal, do the same thing. 13 take away 3 is 10. Now I've got 2 lots of x. I'm going to divide by 2. That'll get x on its own, and x equals 5. So show your steps down here, because if something goes wrong, you can retrace your steps. You can work out, okay, now that wasn't right. I did the divide by 2 first. I did the take away 3 first. And it just helps you just to check if we have problems. I'll do another one. 3x minus 2 now. So remember, to get rid of something, if something's a negative 2, negative 1, 0. If I need to get rid of it, get it back up to 0, I need to add 2. So that's what I'm going to do. I'm going to add 2 to both sides. Negative 2 add 2 is nothing, so I don't need to write it. 3x equals 6. And I've got 3 lots of the unknown, but I want 1 lot of it, so I need to divide by 3. Again, do that to both sides. Now I've got 1 lot of x, and x equals 2. So that's the kind of fluency. They won't ask you this in year 6. They won't ask you this on an arithmetic paper, but it's worth knowing how to do it. 2 key things. Write what you're doing in brackets. Get rid of the odd numbers that are around your unknown first, and then do your multiply or divide. Here is question 3 of a reasoning paper, so it's relatively straightforward. All this question is asking you, so as Dev says, I had £10, I gave some money away. Which expression, it's not an equation because it's not an equal side, it's just an expression. We're not trying to solve the amount he's got. Which expression shows how much money Dev has left? A is the amount of money in pounds that Dev gave away. Now this expression thing, you might think I'm being a bit pedantic, but it's important. When you've got something that's an expression, we're not trying to solve. No one's asking you how much A is. All this question is asking you is, can you understand that he had £10 and he gave a mystery amount of money away? What would that look like in an expression? Well, it's not 10 add A, because he didn't gain more money. We're not dividing by A. We didn't start with a mystery number and give 10 away. We started with 10 and gave a mystery number away. So this is our answer here. Gave some money away is going to be a minus, isn't it? It's going to be a subtract. Gave some money away. And that's all the answer is. It's just asking you to notice we had an amount of money which we knew, 10. We gave away an amount of money which we didn't know, which is A. That's what it would look like as an expression. 1 mark. Well done, me. This gets a little bit more tricky. There's usually something like this on most reasoning papers. The context is always different. It could be shop prints, designs on t-shirts like this or anything. Don't worry about the context too much. They use this formula to work out the price of printing and design. So the price, P, equals 60p times the number of colours, C, we'll call it, add £1.25. That's a formula to work out price. It changes based on the number of colours you have. What is the price of printing a design that has 3 colours in it? So all you're doing is getting that number 3 and plopping it back into your formula. So you've got 60p times the number of colours, add £1.25. So 60p, the multiply comes first because of BODMAS, 60p times 3 because £1.80. And then you're going to add the £1.25. That's a charge that doesn't change based on the amount of colours, and that's usually what they're going to be asking you. They're going to be checking you get that. So the price changes based on the number of colours, and the £1.25 is stuck on at the end. You could call it a delivery charge, a t-shirt, whatever it is. You don't add £1.25 for every other colour you pick. It's separate to that. It's almost as if that is bracketed. Add these up. One, I got 10 there. 1, 2, 3, £3.5p. One mark. And typically they will do this as well. So Amina has £5 to spend on printing a design. What's the greatest number of colours she can have in the design? So we're going to work out how many we could do. I would reverse engineer it if you can do. So we've got £5 over here, 5.00 equals 60p times by colours, add 125. So now we actually have an equation. I can get rid of the 125 because it's an extra charge put on there, leaving me with 375 equals 60p times the number of colours. So how many can I fit in there for 375? Or for how many 60p's am I going to fit in there? Well, I've got 60, 120, 180, 240, £3, £3.60. So I can get one colour in there, 2, 3, 4, 5, 6, but not 7. So I can get 6 colours in there, 2 marks. Depends if you get down to this 375 mark. I think you'd get a mark for that to work out. And then if you get down to 6 colours, you get the full business. But what you're trying to do is just trying to get the unknown, that number of C on its own. But you can use trial and error like this. Okay, I'm just going to work up in 60p's until I don't have any more money than my £3.75. Finally, this is slightly trickier, I've got to be honest. This was from the 2023 reasoning paper. Using formulas again. This formula is used to estimate mass of young children. Honestly, doesn't matter what the context is. Don't get caught up in what we're actually talking about, really. Mass equals 2 times age in years add 5. So there's a bit of bod mass to this. M equals 2 brackets A add 5. Stefan's sister is 4 years of age. Use this formula to estimate her mass. So mass we don't know. 2 lots of 4, because that's what A is, isn't it? Her age. 4 add 5. 4 add 5 is 9, and then 2 lots of 9, 2 times 9 is 18. So 18 kilograms at 4 years old. It's worth logging that slightly, that we think someone who's 4 is going to be 18 kilograms. It's going to help us to check later on what's going on. The mass of Megan's brother is 16 kilograms, less than 18. Use the formula to estimate his age. So now we can start drawing out our formula. We can start drawing out the equation. So we know it's 16 equals, same thing, 2 lots of A, which we now don't know, add 5. The first thing we need to do is you need to actually expand these brackets, which is a bit of a secondary school thing, but it's worth learning at primary. So it means 2 times everything in the brackets, 2 times that, and 2 times that. So 16 equal to 2A plus 10, because 2 times A is 2A, 2 times 5 is 10. Now we can, double equals there just to be totally sure. 16 equals 2A, add 10. I don't need to write 16 again. Because to get A on its own now, I need to take away 10. Because we've got this odd 10 stuck on the end. Take away 10, put it in brackets so I know what I've done. Leave me with 6 equals 2A. And then to get A on its own, I need to divide by 2. And that leaves me with 3 equals A. Put 3 years in. Now check. Okay, 16 kilograms. So we had a 4-year-old up here, 4 years equals 18. Now I've got 16 kilograms, so I'm expecting them to be younger than 4, really. And here we go. We've got someone who's 3 years old. So that makes sense to me. If I came up with someone who was 30 years old and they were 16 kilograms, I'd be thinking something's gone wrong here. So that 2-second check of, does this make sense? Generally, does this age make sense for the question? Yeah, it does. And that is correct. 3 years is the final answer. So that's algebra, flying visit in algebra. If we make it look beautiful and colourful with apples and bananas and things like that, it is simpler on our brain, it makes sense. But when we start realising, okay, we're calling a question mark a letter. We're saying we don't know something, we're going to call that A. We're going to call that X. And you shift things around until you can get that unknown on its own, and then you like reveal it to yourself. So once you start seeing it as a puzzle rather than, oh, what do you mean we've got letters in calculations? It's not about that. It's just shifting blocks around until you can get the individual block that you don't know narrowed down to an individual answer. And that's where the fun is. There is fun in algebra. I'm going to keep saying it until you believe me. It is really good. Secondary school algebra is great. We started in my class having a look at some Key Stage 3 algebra. And some people, once they've got the idea, right, I just need to get the unknown on its own, they were flying into looking into secondary school questions, because once you've got the skill, you can apply it to secondary level. I hope that was helpful. Please share it with people who get stuck with algebra. Share it with someone who you think doesn't like algebra and should like algebra, which is everyone. And if you want me to make a video on a specific thing, let me know. But for now, ciao. See you later.